Drawing covalent Lewis structures is very different from drawing ionic Lewis structures. The reason being that covalent bonds are these highly localized bonds located between two atoms. So where in ionic compounds we just drew the two ions sitting next to each other, in covalent compounds we have to actually show the bonds between each of the atoms. We also have to keep in mind that in the Lewis model of bonding, only the valence electrons participate. So those are the only electrons we're going to pay attention to. So when we draw covalent Lewis structures, the first thing we're going to do is just add up all of my valence electrons, because this is how many electrons we have to form bonds. Now, not all of those are going to be used to form bonds. Some of those are simply going to be used to give every atom an octet. That's why the atoms are forming bonds, so that they can achieve an octet and become more stable. After we add up our valence electrons, we'll draw the basic structure of the molecule, where we show how the atoms are connected to each other. There has to be at least one bond holding two atoms together, so we're going to go ahead and draw those in, and each bond uses up 2 of the electrons. When we draw the structure, the less electronegative atoms like to go in the middle, the more electronegative atoms like to go on the outside, and hydrogen atoms are always on the edges. They can only form one bond, so they can never ever go in the middle. After we make this basic structure, we're going to give away the rest of our electrons, trying to give every atom an octet. Life is a little easier if we give those electrons to the outside or terminal atoms first, and then move in and try and give an octet to the atoms in the center. We also always give electrons away in pairs, never one electron at a time. Sometimes we'll actually run out of electrons before we've been able to give everyone an octet. In that case, then we can form a double or a triple bond, which is where we make an atom share more than one pair of electrons with its neighbor. We only do this if we run out of electrons. We never start off by giving double or triple bonds. This is a last resort to give everyone an octet. So let's look at a couple examples. Let's start with CH4 here. So the first thing we're going to do are add up the valence electrons. Carbon has 4, and hydrogen has 1, but we have 4 of them, so we'll multiply that by 4. So 4 plus 4 gives me 8 valence electrons total. Now I'll draw the basic structure. Got a carbon, he's the less electronegative, so he goes in the middle, and my hydrogens have to go on the outside. So I'll draw those around there. I have 4 bonds here. And so each of those contains 2 electrons, so 4 times 2, I've used up 8 electrons just for bonding. I have 0 left, and now I can see, okay, I want to check, does everyone have an octet or a duet? Is everyone happy? Once hydrogen has a bond, they're happy. So all of these hydrogens, they're totally happy, no problem. Carbon sees 4 bonds, and each of those bonds has 2 electrons. So carbon sees 2 electrons here, 2 electrons here, 2 here, 2 here. It sees 8 electrons total. It has an octet, so he's also happy. So we're done. That one's really, really easy. Let's try a little bit of a harder one. Let's try C2H6. So now I have 2 carbons. Each one has 4 electrons. And I have 6 hydrogens, and each one has 1 electron. So I have 8 here, I have 6 here, so I have 14 valence electrons total. Now I'm going to draw the structure. Again, the carbons have to go in the middle. I'll connect them. And then I have 6 hydrogens, so I'm going to just evenly distribute them around. So I'll put 3 on this carbon, and I'll put 3 on this carbon. All right, now I need to subtract out how many electrons I use for bonding. So I have 1, 2, 3, 4, 5, 6, 7 bonds. Each one has 2 electrons, so that's 14. Okay, I've used up all my electrons. I know all the hydrogens are happy. Each carbon has 4 bonds around it, therefore each carbon is happy. So I'm done. Lewis structure is done. Now that's not always going to be the case, so let's look at another example. Here we have C2H4. So again, 2 carbons, each one has 4, so I have 8 electrons there. I have 4 hydrogens, each one has 1 electron, so I'll have 4 there. So now this time I have 12 valence electrons to give away. And going to put the carbons in the middle. This time I have 4 hydrogens, but I'm still going to try and evenly distribute them. So I'll put 2 on this guy and 2 on this guy. So far I've used 2, 4, 6, 8, 10. So I have 2 valence electrons left. And so I'm going to start trying to give everyone an octet. So I put 2 electrons there, and we can see this carbon on the right has an octet, but the carbon on the left only sees 3 bonds, so he is not yet satisfied. So this is the case. We've given away our other 2. We have no electrons left to give. Now we have to start sharing. So the hydrogens can't share anymore, but this carbon, he has an extra lone pair. So what we can do is we can put this lone pair in the middle and form a double bond. So it goes away over here. We have a double bond in the middle. And now we can see each carbon sees 4 bonds, 2 single bonds with hydrogens and 1 double bond between the 2 carbons. So we only made that double bond at the end because we had run out of electrons. All right, let's look at one more example. This one is an ion. Here we have NO3 minus. So nitrogen has 5 electrons. We have 3 oxygens. Each of them has 6, so that's 18 electrons. And then notice we have this negative charge here. That means we have an extra electron. So I'm going to add that one in. So I've got 24 valence electrons total. So we have NO3. Nitrogen is less electronegative, so he's going to go in the center. And then I'm just going to connect my 3 oxygens. So I've already used 6 valence electrons for bonding, so I have 18 left. So I'll just start giving them to my outside atoms. So I'll do 2, 4, 6, 8, 10, 12, 14, 16, 18. So now I've run out, no more electrons left. So all of my oxygens have their octets, but my nitrogen here only has 3 bonds. That's 6 electrons. He's not yet satisfied. So we're going to do the exact same thing we did in the last example. We're going to make one of these oxygens share his electrons. Doesn't matter which one I choose. We're going to talk more about that when we talk about resonance structures. But for now, I can just pick this guy on the right, and I'll say, all right, you're going to use those and put them in here. So I'm going to take them away from there, and now I have a double bond between this oxygen and nitrogen. So the oxygen still has an octet because he has 2 lone pairs, that's 4 electrons, plus the 2 bonds, that's another 4, that's 8. The nitrogen has an octet because he has 4 bonds, 2, 4, 6, 8 electrons total. And each of the other 2 oxygens has an octet because they have 6 lone pair electrons and then 1 bond, that gives it an extra 2, so that's 8. Because this is an ion, like we do with all ions, we'll put him in brackets and we'll put his charge on him.